array versus linked list visually, like no syntax, no code, just how the theory works, how the memory allocation will be going on. When you store data in code, your computer's RAM doesn't care about your logic. It only cares about memory layout. The array. First let's go with the array. Think of array like a booking a row of seats at a movie theater for you and your friends. You all sit right next to each other in a continuous unbroken line. In computer memory, this is called continuous memory allocation because every single watch sits at a fixed address right next to the previous one. The computer doesn't need to search for element number tree. If you want to search element memory, it doesn't need to search for element. It does a quick math calculation and it instantly goes to address 112. Now we will see how insertion works in the array. See, like now we have discussed about a movie, friends sitting in a movie row, right? Now think like what happens when a late friend shows up and wants to sit right in the middle of it index one. It will become a disaster because the memory is locked in a shit row. Every single person from index one to the end has stand up and shift one seat each to the right just to make a room for the one who came newly. Think of it like if you have a 1 million items in an array. Adding or deleting one item near the front means shifting a million items in a memory. It will be a lot of disaster. Now we'll be discussing about linked list. Think of it like a linear data structure where elements are not stored in neighboring memory locations. In linked list, instead of demanding seats right next to each other, the linked list will be telling like wherever there's open space in memory, sit there. Think of it like a scavenger hunt. Scavenger hunt is nothing but a game where players receive a list of specific items to gather or riddles to solve. Like players move from one location to other to find each item. Each box called a node holds two simple things, your actual data and a slip of paper holding the memory address where the next node is sitting. The slip of paper is your pointer. They are not next to each other physically, but they are linked together logically. Now, think of this as a linker list. This whole called is a node. In this node, it will be two paths. This is data. This is pointer. The pointer will be always holding the next node's data. Next node's address. Now we'll be seeing how linker list insertion works. See, like, what if we want to insert the new element 99 right in the middle? Now between them. So So we just drop the new node anywhere in the memory, like snip the arrow from node 1 and attach it to the one new node and also point our new node to node 2. It's like unclipping a chain and snapping a new link and closing it. Finishing everything. It will be easy and fast. See, now from the previous one, this is node 1, this is node 2 and this is node 3. Now think of only two nodes are there, node 1, node 2. The direct connection between node 1 and node 2 is in this way. Now, you want to add node 99 in between both of them. So, from in the previous, like node 1 pointer is directly pointing to node 2, change it to this way. Node 99. See, it will be connected to node 99 and the connection to node 2 will be lost. So, to connect node 2, you will be connecting from node 99 to node 2. This is how the chain works in linked list. So, which one is actually better? It completely depends on what you are going to do. What you are going to build or what your project is. So, choose an array when you know the fixed size of your data and you need to randomly access or read elements super fastly. And choose a linked list when your data size is constantly growing or shrinking and you are frequently adding or removing items from the middle. And that's how computer memory actually works. If the visual breakdown help you clear the things for you, if you understand it, just hit the subscribe button, drop a like, comment below like what we need to discuss next. Do subscribe and share for others also.